All right, welcome back. Hononegah Honors Algebra 2. 7.2 Day 2, and this is one of the most important sections that we will do in Chapter 7. And we're going to start going through all the different rational functions where the asymptotes occur for a vertical asymptote, a horizontal asymptote, even an oblique asymptote, and holes. So again, we are dealing with a fractional function. And we're no longer adding and subtracting. Yesterday on the 7.2 Day 1 notes, there was an addition or subtraction at the end that became our horizontal asymptote. And so we won't have that anymore. We will have just one fraction. And so we have to figure out, when does a vertical asymptote occur? When does a horizontal asymptote occur? When does an oblique? And when are there holes? Let's first talk about vertical asymptotes. A vertical asymptote occurs when the denominator is 0. So they occur when most values of x that make the function undefined. So when 2x minus 1 equals 0, there is a vertical asymptote, and I'll abbreviate VA, vertical asymptote at x equals a half. And there's also a vertical asymptote when x equals negative 5/3. So again, these are lines. Asymptotes are lines that the graph will approach but not cross. And there's a couple of cases where it will cross, but for the most part, they're graphs. They are lines in the graph where the graph will approach but not cross. This page, put a star by it, put an asterisk by it. It's the biggest page that we have going. So if you have this is all about horizontal asymptotes. When do horizontal asymptotes occur? There's three cases. First, if the degree of the top is smaller than the degree of the bottom. So notice you have an x squared on top and an x cubed on the bottom. Anytime the degree of the top is smaller than the degree of the bottom, it's an automatic horizontal asymptote at y equals 0. So I'm going to do another example there. 1 over x. That has a horizontal asymptote at y equals 0. And yes, it does matter about the y equals and the x equals. I should go back. All the vertical asymptotes will be at x equals, and all the horizontal asymptotes will be at y equals. So if you do not put the letter with that, again, you will get points taken off. So case number 1, degree of the top smaller than degree of the bottom. Next, I'm going to erase here. If the degree of the top is the same as, so notice that the top is x to the first and the bottom is also x to the first. So the degree of the top is the same as the degree of the bottom. The coefficients make the horizontal asymptote. So I'm going to do another example over here. Y is equal to 7x plus 1 over, let me make this a little bit better. Sorry about that. Let's go 3x plus 1 over x minus 2. So the horizontal asymptote, because the degree of the top is the same as the degree of the bottom, the horizontal asymptote would be y equals 3, which is 3 over 1. So again, the horizontal asymptote, if the degrees are the same, are the coefficients. Now, some of you might ask, well, why is that? If I went x all the way to 1,000,000, and then I went x on the bottom all the way to 1,000,000, you'd end up with 3,000,000 over 1,000,000. So again, as you continue to go bigger and bigger and bigger, you're going to get closer and closer to 3 being that horizontal asymptote. And the last one is the most complicated one. What happens if the degree of the top is larger than the bottom? Then there is no horizontal asymptote, but there could be what's known as an oblique asymptote. The oblique asymptote occurs when the degree of the top is exactly 1 larger than the degree of the bottom. So no horizontal could be an oblique. And obviously in this class, we're going to create situations in which the function has a degree on the top 1 larger than the degree on the bottom. So those are your three cases. If it's smaller, degree on the top is smaller than the bottom, auto y equals 0. If the degree on the top is the same as the bottom, coefficients. And if the degree of the top is larger, then no horizontal, could be an oblique. Here we go. Let's do some next, sorry. Point of discontinuity, which I will refer to the rest of the time as a hole. Anytime there's a situation in which the top and the bottom cancel. So if something cancels from the top and the bottom, sorry, handwriting there, cancel, then whatever value makes it 0, so whatever you canceled, whatever makes it 0, there becomes a hole in the graph. So what happens is, literally, as the graph is going along, you would put a hole in the graph, or what's known as a point of discontinuity, meaning the graph is going along and then it skips over that particular value and then continues to go. So a point of discontinuity, or hole. Oblique asymptote. Now, I know it says it here, but how do I find an oblique asymptote? When the degree of the numerator is exactly 1 greater than the degree of the denominator, you want to calculate the oblique asymptote by long division. The oblique asymptote will occur when you divide using long division. With that being said, let's go back and talk about, I know the answers here, but let's talk about how do I calculate long division. Take the first term and the first and decide what. So x, always subtract, which basically changes the signs, and pull down the next one. Starts over again, x plus 2, positive 2, subtract, and you get a remainder of 4 over x minus 2. Now, the remainder does not count when going to the oblique asymptote. Reason? Because if x goes to infinity, this ends up becoming 0. So the oblique asymptote would be y equals x plus 2. Notice the oblique asymptote is a line. So in the graph, when we actually have one of these in the picture, you'll see that the oblique asymptote is a line that the graph will come close to, but not actually cross. All right, here we go. So there's, on the test, when I give you this question on the test, there will be vertical asymptote blank, horizontal asymptote blank, oblique asymptote blank, and hole. So it'll be a blank for each one of these. So start with the hole. If anything in the top and the bottom cancel, then you should do that first. And sometimes there isn't one, so just put an X through that. Didn't happen, or just put nothing there. Not applicable. No hole. Next, factor. If I can factor the bottom and I can factor the top, I should do that. So again, nothing's canceling. Vertical asymptotes occur where the denominator is 0. So there's an x equals -5 and an x equals 2 vertical asymptote, because I can solve this equaling 0 at -5. And I can solve the other one for x equaling 2. So those are vertical lines that go through the graph. Next, the degree of the top compared to the degree of the bottom. Now, there's never both of these. So you're either going to have a horizontal or an oblique, but you'll never have both. So since the degree of the top is smaller than the degree of the bottom, there is no oblique and an automatic y equals 0 horizontal. Next, you got to decide where to actually graph this. Here's what I will tell you. When graphing, take your vertical asymptote and do a number on either side of your vertical. So vertical asymptote at -5, so I did -4 and -6. Vertical asymptote at 2, so I'm going to do 1 and 3. And all you need are 4 dots. I can tell you everything you need to know about this picture just from those 4 dots. So plug -4 in for x. If I plug -4 in for x, I'm going to get negative, and I'm just going to leave it not reducing it. So 4, 6. So -2/3 if you wanted to reduce it. So at -4, 1, 2, 3, -4, -2/3. So down here. Next one, -6. I'm going to get 4 on top, and I'm going to get positive 8 on the bottom. So positive a half up here. 1, if I plug 1 in, I'm going to get 4 on top and negative 6 on the bottom. So 1, negative 2/3, so down there. And then 3, 4 on top, 8, 1, I'm going to get positive a half. Those 4 dots tell me everything. Because the dot was above, it's going to be in this area along the asymptotes. In the middle, you'll notice it's below, and along the asymptotes. And the last one, it was above the horizontal asymptote, so again, along the asymptotes. Now, some of you are going to say, can I put this into my graphing calculator? Yes, it will probably show you the picture a little bit, but where you're going to have issues is it's not telling you the vertical asymptote. It's not telling you the horizontal asymptote. It's not telling you that there is no oblique or there is no hole in the graph. Next one. Ooh, a lot of stuff going on here. I'm going to make my blanks now. Vertical asymptote, horizontal asymptote, oblique asymptote, and hole. First thing I should look for is a hole. So if the top is factorable, which it is, I should do that. If the bottom is factorable, which it is, I should do that. And I see there's a hole. Something is going to cancel. So when I cancel those two out, I now have a hole when x equals 4, and I write down what's left. So I'm still going to graph what's left. It's just no longer having the x minus 4 involved. The x minus 4 is gone. That created the hole. When I go to graph it, you'll see what I mean. Next. All right, so vertical asymptote. X equaling 0. If x equals 0, it causes the denominator to be 0. So I have a vertical asymptote at x equals 0. The degree of the top is the same as the degree of the bottom. So there is no oblique then. And I take the coefficients in front, and that's the horizontal asymptote. So the horizontal asymptote is at y equaling a half. Now for the graph. All I want to do is an XY chart, and I want one number on either side of the vertical. So if I plug 1 in, and again, you're going to plug it into this one here. I'm going to plug 1 in, and I'm going to get 4 on top and 2 on the bottom, or just 2. So 1, positive 2. There's a dot. Maybe I should put that in black just to give it a different color. Next, I'm going to put negative 1 in. So that's positive 2 on top, negative 2 on the bottom, or negative 1. All right. So I'm going to make the graph, but there is a hole in it. So here's the graph. It goes along the asymptote and along the asymptote. This one goes along the asymptote until you get to 4, and you put a hole in it. So I'm going to recap what I did. I factored the top, factored the bottom, something canceled. Because something canceled, there's a point of discontinuity or a hole in the graph. With that being said, the value that is canceled, what makes it 0, does make the hole. Then I graph what's left after I factor. Because the degree of the top is the same as the bottom, you end up with the coefficients for your horizontal asymptote, and your vertical asymptote occurs because of the value of x that makes the bottom, or the denominator, 0. Next one. All right, so vertical asymptote, horizontal asymptote, oblique asymptote, hole. Don't presume anything. The top is factorable, and the bottom is not. Something cancels, so that makes a hole. So there's a hole when x equals 2, because that is the value that makes that parenthesis 0. So there is a hole. Now, graph what's left. Well, wait a minute. What's left isn't a fraction anymore. So there is no vertical asymptote. There is no horizontal asymptote. There is no oblique asymptote because it's not a fraction. We have a positive 2 with a slope of 1. So to make a long story short, this is a line with a hole in it. If you were to type this into a graphing calculator and went to the XY chart, you will notice the points that you would graph, but if you go to an actual 2, it's going to say error because it's a hole. Next one, and again, this is about as complicated as this is going to be. Vertical asymptote, horizontal asymptote, oblique asymptote, and hole. The top is actually factorable and the bottom is actually factorable, but nothing cancels. So that takes out the hole. Nothing's going to cancel. With that being said, is there a value that makes the bottom or the denominator 0? Yes. X equaling 1 would cause the denominator to be 0. So x equaling 1, vertical asymptote. All right, the degree of the top is larger than the bottom. So that takes horizontal asymptote out. How do I get an oblique asymptote? I long divide. X to the 4th, 3x cubed, no x squared, no x, no 0. All right, here we go. Look at the very first term. X cubed to get x makes x to the 1st. Would then get you x to the 4th minus x. So notice that I put it under the correct column. Change the signs to subtract, pull down the next one, and in fact, you can pull down all of these. I'm going to give myself more space here. X cubed to get 3x cubed, positive 3. 3x cubed minus 3. Change the signs to subtract. And so now, notice that you have no x squared. You do have 1x plus 3. The trouble is the degree now is bigger than that you're dividing into. So now your oblique asymptote is y equals x plus 3. Let's graph this now. And I kind of got in my own way there. So I am going to erase this, but that was the long division. So I got a little bit into my graph. So I'm going to erase this just so I can look at the graph a little better. All right, here we go. Y equals x plus 3. Positive 3 is the y-intercept with a slope of 1, and it is an oblique asymptote. Some people also refer to that as a slant asymptote. XY chart, I need one number on either side of the vertical asymptote. So if I put 0 in, I'm going to get 0. If I put 2 in, I've got to work a little harder here. 2 to the 4th power is 16 plus 24. So I get 40 on top when I put 2 in, and I get 7 on the bottom. So 2, and then if I wrote that as a decimal, it's 5 and 5.7. So coming over here now to the graph, 2, 1, 2, 3, 4, 5, a little over, and 0, 0. What this means is going along the asymptote, along the slant or oblique asymptote, and then along the vertical asymptote. Along this vertical asymptote and along the oblique. So that is about as hard as I can make it. And again, if you type this into a graphing calculator, it would show you what it's going to look like, but it won't tell you what the oblique asymptote is and what the vertical asymptote is. On your graphs, you have to actually draw in the vertical and oblique asymptotes. You got a homework assignment tonight. It's a worksheet. Good luck. This can be a very challenging. This is the majority of the Chapter 7 test comes from this particular section. So make sure that you're asking questions if you have any, and good luck.